In example 3C, our system is negative 2x plus 2y is equal to negative 20, and then x minus y is equal to 10. Okay, so we will again solve this by substitution. Okay, so first step, we are going to solve for one variable. Okay, so let's analyze this. Let's look at the system. We're going to pick one of the equations, okay, and solve for one of the variables. When I'm looking at these two equations, okay, in the first equation, notice there are numbers or coefficients in front of the x and the y. And so, you know, and then if you look at the second equation, you don't have that. There's ones in front of the variables. And so in that case, it's probably easier to work with equation 2 to solve it for one of the variables. So I'm going to go with equation 2. Okay, so I'm going to pick equation 2 because I feel like it's easier to work with. If you had instead picked equation 1, that would be fine. It's going to come out, if you do your work correctly, you should get the same answer. All right, but I just feel like, you know, equation 2 is easier to work with. All right, so now we need to solve for one of the variables, okay? The previous two examples I've solved for y, so let's solve for x. Okay, so I'm going to add y to both sides, okay? But of course, you could have solved for y, okay? You're going to get x is equal to y plus 10, okay? All right, so now what we need to do is go ahead and substitute that information into the other equation. I cannot emphasize that enough. If you substitute this information into the equation you used to get it, it's going to be like you're going to end up where you started. It doesn't work. So once you solve for one of the variables, you have to plug that information into the other equation, okay? So we have not used equation 1 yet, okay? So now I'm going to go to this equation and I'm going to use the fact that x is the same thing as y plus 10, okay? So I'm going to go to this equation. Everywhere I see an x, I'm going to put y plus 10. So we're going to have negative 2 times, okay, you have to use parentheses because y plus 10 is a package deal. X is the same thing as y plus 10, okay, and then continue on with the equation. So we're going to have plus 2y is equal to negative 20, okay? That leaves you with an equation with just a y, so you're going to be able to solve for y. Okay, so we're going to get negative 2y minus 20, don't forget to distribute, okay, plus 2y is equal to negative 20, okay, and then look what happens here. You have a negative 2y which cancels with a positive 2y, okay, so you're left with negative 20 is equal to negative 20. Okay, the variables are gone, okay, and you are left with a true statement, okay, negative 20 always equals negative 20. So what does this mean? We were trying to solve for y, and we ended up with this statement, negative 20 is equal to negative 20, okay? Well, remember, when you're solving a system of equations, there are 3 possibilities. There's either exactly one solution, okay, one xy pair that works, or there's no solution, or there's infinitely many solutions, okay? So there is not a unique solution here, okay? There is no one XY pair that works, because if there was, we would have been able to get it, okay? So something else is going on here. This is either no solution or infinitely many, okay? So the question is, which one is it, okay? Well, it all depends on whether you get a true or false statement. This is a true statement, okay? And so in that case, since it's a true statement, there is a solution, okay? There's just infinitely many of them, okay? So getting a true statement indicates infinitely many solutions, okay? So there are infinitely many solutions. If you had gotten something false, so say something like 0 equals negative 20, that would have been no solution, okay? So that means there's lots and lots of XY pairs that work, okay? This is telling you that since there are infinitely many solutions, these two equations represent the same line, okay? Now remember, infinitely many solutions does not mean any single XY pair works, okay? It only means that points on the line are solutions, okay? The equations represent the same line and every single point on that line is a solution, okay? So to be a solution, it has to be a point on the line, okay? So you have to parameterize here because there's infinitely many, okay? So let's walk back through the steps because we've only done this once about how you parameterize, okay? You are going to take one of the equations, they are the same equation. You're going to take one of the equations and solve for one of the variables, okay? We've already done that, okay? So go back to this step, okay? So you need to analyze this, okay? Remember, when you parameterize, you're changing over to another variable, okay? We usually use t, okay? So you look at this and you say, okay, which variable am I in charge of? Okay, well, if you look at this, you're in charge of y. If you pick the y value and you plug it in, you have to, this tells you how to get the x value from the y value. So you are in charge of y, and then you plug in that y value, you add 10 to it, and that's how you get the x value, okay? So that means that the y value is the t value because we're in charge of the y value, okay? And then to get the x coordinate, okay, it would be y, which is t, plus 10, okay? So here is one way you can do the parameterization, okay? Remember, you could have, you know, solved for y instead, okay? You didn't have to do that here because you already did the work to solve for x, but you would have gotten a different looking parameterization, but if you did it correctly, it should represent the same ordered pairs, okay? All right, so here's the parameterization, okay? This is going to generate every single point on this line. These equations represent the same line, okay? I might ask you for a specific solution, okay? So this is the parameterization. And again, I don't ever know if I'm spelling this right. Okay. I could ask you for a specific solution, meaning give me an XY pair that actually works and is a solution to this, okay? So all you have to do is pick a t value, okay? I'll pick t equals 0, okay? So if t is 0, then it's going to be 0 plus 10, so the x value would be 10, and the y value would be t, which is 0, okay? You can go and check that that works, okay? So negative 2 times 10 is negative 20, plus 2 times 0 is 0, so that's going to give you negative 20. That's correct, okay? Or if I did 10 minus 0, that gives me 10, okay? So this is a specific solution. This would be the x coordinate, this would be the y coordinate, okay? I could generate another specific solution, pick a different t value, okay? Maybe t is 2, okay? If that's the case, then 2 plus 10 is 12. That would be the x coordinate, okay? And then the y coordinate would be t, which is 2, okay? So that's another specific xy pair that works, okay? And you can check it, okay? So you could do negative 2 times 12, that's negative 24, plus 2 times 2, that is 4, so negative 24 plus 4 gives you negative 20, that's correct. And then on the other equation, 12 minus 2 does give you 10, okay? So again, only points on the line are solutions, okay? And when you write down the parameterization, it helps you generate all the points on the line, okay? By picking a specific t value, you can get a specific xy pair that is a solution to the system. All right, let's try one more by substitution, and then we will move on to elimination, okay? All right, so here's our last one. This is example 3D at the top of page 7. Okay, so here we are. Okay, so our system is 3x minus 2y is equal to 30. And the second equation is negative 6x plus 4y is equal to 30. Okay, all right, so again, we need to start by picking an equation and solving for one of the variables. All right, so both of these equations look pretty complicated, so I'm just going to randomly pick the first one, and I'm going to solve it for one of the variables. Okay, I don't know, I'll solve it for x. You can solve it for y. It doesn't matter, okay? All right, so I'm going to add 2y to both sides. Okay, so I'm going to get 3x is equal to 2y plus 30, okay? Divide both sides by 3. Everything gets divided by 3. Okay, so I'm going to get x equals 2/3 y plus 10. So yucky, yucky, we got a fraction. Okay. All right. So now what we're going to do is go ahead and do the substitution step. Okay. I obtained this information from equation 1. So we're going to plug this result into equation 2. So go ahead and write that down. Okay. Everywhere we see an x, we're going to replace it with 2/3 y plus 10. Okay. So I'm going to have -6. Okay. X we're going to have to put in parentheses. X is the same thing as 2/3 y plus 10. Okay. And then continue. So plus 4y is equal to 30. Okay. Our equation now has just a y. So you're going to be able to solve for the y. All right. So you're going to have to distribute here. Okay. You're going to get -6 times 2/3 y. And then -6 times 10 is -60. Plus 4y is equal to 30. Okay. And then let's go ahead and tackle this fraction. Okay, you could put this in your calculator, -6 times 2/3, or you can do it by hand. Okay, you can make anything a fraction by putting it over 1. To multiply fractions, you multiply across the top and across the bottom. So this is going to be -12/3 y minus 60 plus 4y is equal to 30. Okay, and so if I come up here, -12 over 3 is -4 times y minus 60 plus 4y is equal to 30. Okay. On the left side, you have a -4y, which cancels with a positive 4y. You are left with the statement that -60 on the left is equal to positive 30 on the right. Okay. That is a false statement. Okay. -60 never equals 30. Okay, the variables are gone. Okay, it is impossible here to solve for the x or y. Okay, so again, there is no unique solution here. Okay, since we got a false statement here, this is the case of no solution. Okay, if you had gotten a true statement, like in example 3c, that would have been infinitely many. Okay, but false statement indicates there is no XY pair that makes both of these statements true at the same time. Okay, graphically, that means these are parallel lines. Okay, all right, so that's how substitution works. Okay, we're going to move on now and we're going to look at the last method you can use to solve a system of 2 linear equations and 2 variables, and that is elimination.